Hi friends, in this video I want to see about the problems on single plate and multi-plate clutches. So let us assume a problem now. So a car engine develops a maximum power of 15 kilowatts at 1000 rpm. The clutch is used as a single plate type, both the side effective, having external diameter as 1.25 times of the internal diameter. So mu, the coefficient of friction given as 0.3. The maximum axial pressure is not to exceed 0.085 Newton per mm square. So determine the dimension of the friction surface and the force necessary to engage the plates. So assume uniform pressure condition. So what are the conditions they given? That is, the data given is n is equals to 15 kilowatts. So n they given, that is rpm, 1000 rpm. So d2 is 1.25 times of the d1. So the coefficient of friction mu is equals to 0.3 and the pressure intensity is 0.085 Newton per mm square. They asked us to assume uniform pressure condition, and they said that both the sides are effective for a frictional lining, that is I is equals to 2. So the first step will be torque transmitted. So I want to assume the equation, that is 19.3c. So mt is equals to 9550 into 1000 multiplied by n by n. So I want to substitute the formula, values of the power as well as the rpm. So I want to get mt as 143250 Newton mm. So once you got the torque, so I have to go for the mean diameter. So the mean diameter is, I going to take 5. Given condition is uniform pressure condition. So dm formula will be dm is equals 2 by 3. So d2 cube minus d1 cube divided by d2 square minus d1 square. The equation number will be 19.85a. In this case, they are not given the d2 and d1, but they given a condition as d2 is equals to 1.25 times of d1. So that I want to substitute now. So it will be 1.25 times of d1 cube minus d1 cube divided by 1.25 times of d1 square minus d1 square. I'm going to simplify this overall equation. So I'm going to get dm in terms of d1. That will be dm is equals to 1.13 d1. So keep this equation as it is. So now I go for the third step, that is axial force. So again uniform pressure condition. So Fa is equals to pi into P, d2 square minus d1 square by 4. Again d2 I am going to substitute as 1.25 into d1. So I am going to get that simplification of the equation. I am going to get Fa is equals to 0.037552 into d1 square. So keep this 2 as it is again. So I'll go for the next, that is the dimension. So again dimension I'm going to use the same torque formula, that is mt is equals to half mu Fa dm into I. So mt already calculated in the first step. So that is the value got as 143250. So keep as it is 1 by 2. So mu is given in the equation, that is 0.3. So they given so you already calculated Fa, that is 0.037552 into d1 square, and dm in terms of again d1, that is 1.13 into d1 into 2. So I have taken as 2 because both the side is effective. So from this equation, when I want to simplify, I want to get d1 is equals to 224 mm. So therefore d2 will be equals to 1.25 into 224. So I want to get as 280 mm. So dm is equals to 1.13 into 224. So it will be 253 mm, that is the mean diameter. So axial force, so the equation will be 0.03755 into d1 square. So I am going to substitute d1 square. So I am going to get as 1884.21 Newton. So I am going to assume thickness of the plates as h is equals to 2 mm. So that I want to take from the equation 19.92. So that is the complete calculation for a given problem. So next we got to assume another problem. So single plate frictional clutch of both the side effective has a 0.3 mm outer diameter and 0.16 inside diameter. The coefficient of friction is 0.2. It runs at 1000 rpm. Find the power transmitted for a uniform wear and uniform pressure distribution cases if the allowable maximum pressure is 0.08 MPa. So in this case they already given the d1 and d2. So no need to calculate d1 and d2 again. So what are the given data is I they given as 2, that is number of frictional surfaces, effective frictional surfaces. So d2 is 300, d1 as 160 mm. So coefficient of friction is 0.2. So n they given as rpm, that is 1000 rpm. So p they given as 0.08 Newton per mm square. They ask us to calculate a capital N, that is the power transmitted. So we are going to consider uniform wear condition. The axial force Fa is equals to, the formula will be half pi p d1 multiplied by d2 minus d1. So that is equation number 19.83. I am going to substitute all the values because p is known, d1 is known, d2 is known. I am going to substitute all the values. I am going to get Fa as 2814.867 newtons. So the mean diameter formula is dm is equals to of d2 plus d1. So I'm going to substitute again the d2 and d1 values. I'm going to get dm as 230 mm. So what is the torque transmitted? That is mt is equals to of mu fa dm into I. So mt is equals to of 0.2, that is mu. Fa value I'm going to substitute over this, and dm which is calculated over the 230, that is, and I is equals to 2. I'm going to get mt is equals to 129,483.882 Newton mm. So now once you got the torque, so I'll go for the power transmitted, that is N is equals to I mu P N into D1 multiplied by D2 square minus D1 square divided by 24,305 into KL. KL is nothing but the load or service factor, so I can assume that value as 1. So N is equals to, by substituting all the values of this, that is I is known, mu is known, P is known, N is given, and D1 is given, D2, D1 is given. So KL I am going to assume as 1. So by substituting all the values, I am going to get N is equals to 13,566.2 watts, or you can say that 13.566 kilowatts. This is when you want to use the uniform pressure theory. So uniform wave theory, that is. So coming on to uniform pressure theory now. So Fa is equals to pi p d2 square minus d1 square divided by 4. So I'm going to get Fa as 4046.37. So only Fa I'm going to change because all other things remains the same. So I'm going to go for the same formula now. So I mu Fan divided by 28,364 KL multiplied by d2 cube minus d1 cube divided by d2 square minus d1 square. I'm going to substitute all the values. So I'm going to substitute, I'm going to get power as 20.103 kilowatts. So this is in the uniform pressure theory, and I go for uniform wave theory, I'm going to get pressure power as 13.566 kilowatts. So this finishes the given problem. So let us consider the next problem now. Design a single plate clutch used in automobile transmitted for a following specification of power to be transmitted is 20 kilowatt. The speed is 1500 rpm to 2500 rpm, that is the minimum to maximum. The friction surface molded as asbestos on steel. So the friction material will be asbestos and it will be placed on a steel. So what are the given data? So N is given as 20 kilowatts. So N1, that is the minimum speed is 1500 and maximum speed is 2500. The friction surface is asbestos on the steel. So assuming I is equals to 2, that is both the sides are effective. From a table 19.7 for asbestos and steel, so mu will be given as 0.2 to 0.5. So and the pressure will be given as 0.3452 to 1.0346 megapascals. So for this particular problem, I am going to select mu as 0.3 and P as 1 MPa. So assuming the C40 steel for the shaft, since the D1 is not given and D2 not given, I have to find out the shaft diameter, that is small d. So for that I am going to assume the material, the shaft material as a C40 steel and FOS as 3, factor of safety as 3. So from the table 1.5, that is volume 1, so I can get the yield stress, that is sigma y is equals to 328.6 megapascals. So from that I can find out sigma, that is yield stress divided by factor of safety, that is 328.6 divided by 3. I am going to get as 109.53 Newton per mm square. That will be the stress. So for calculating the shear stress, it will be 0.5 of the stress, that is 0.5 into sigma. I am going to get as 54.77 Newton per mm square. That will be the shear stress to S. So assuming the QA factor, I am going to assume the QA factor as 0.75. So these are the values I am going to assume in the case the D2 is not given, or ratio also not given in the particular problem. So now the first step will be again the torque transmitted. So MT is equals to 9550 into 1000 into capital N by small n. So MT is equals to 9550 into 1000 into 20 by 1500. So I'm going to get MT as 127,333.33 Newton mm. So now diameter of the shaft. So small d is equals to cube root of 16 MT pi tau s into QA factor. So I want to substitute the value 16 MT value pi and tau s which you calculated and the QA factor as 0.75. So I'm going to get small d as 25.08 mm. So now for this you have to go for the standard. I can't use the 25.08, so I should go for the standard. So from the table 14.6, the standard shaft dia I am going to assume as 30. I can't go lesser than this. It should be more than this. So After 25.08, the standard diameter of the shaft is 30 mm. So I'm going to consider D is equals to 30 mm. The mean diameter, for considering this as a uniform wear condition, I'm going to get dm is equals to half d2 plus d1. So d1 and d2 are both are unknown, but in equation 19.91 we have an equation that d1 will be equals to 4 times of small d, that is shaft diameter. So d1 is equals to 4 into 30, so d1 will be 120 mm. That I want to substitute over here. So dm I going to get in terms of d2. So again the axial force, again I'm going to substitute d1 as 120, so I'm going to get FA as in terms of d2 now. So at last the dimension, so mt is equals to half mu FA into dm into I. So in this equation I'm going to substitute FA in terms of d2 and dm in terms of d2. So I'm going to find out d2 value. So d2 I'm going to get as 135.13 mm. So I'm going to assume d2 as 140 mm. So the axial force will be FA is equals to 188.5 into 140 minus 120, I'm going to get as 3070 Newton, and H, that is the thickness of the plate, as 2 mm. So that finishes the problem. So considering the fourth problem, a 25 kilowatt at 300 rpm is to transmitted by a multi-frictional clutch. The plates have frictional surfaces of steel and phosphorus bonds alternatively and run in oil. Design a clutch for 25% overload. So in this case, they are given a multi-plate frictional clutches, and they are given two frictional plates, that is phosphorus bronze and steel. So alternately it will be placed. So and it will be running in oil. The given data is N is equals to 25 kilowatt and small n, that is RPM, will be 3000 RPM. The overload is 25% and frictional material will be steel and phosphorus bronze. So from table 19.7, for a steel and phosphorus bronze, the mu is given as 0.3 and P is 1.0346 Newton per mm square. That I want to assume directly. So for calculating the D, that is shaft diameter, this time I am going to assume as C30 steel and FOS as 3. So from the table again 1.5 for a carbon 30% steel. So sigma y is given by 294.2 megapascals, or you can take that one as 294 Newton per mm square. So sigma, it is divided by the FOS, so I am going to get as 98.06 Newton per mm square. So the shear, it will be 0.5 times of this, that is stress, so I am going to get as 49.23 Newton per mm square. Again I am going to assume QF factor as 0.75. The first step will be torque transmitted. So MT is equals to the same formula, 9550 into 1000 into capital N by small n into overload percentage. So MT is equals to 479.16 Newton mm. So diameter of the shaft, so D is equals to cube root of 16 MT pi tau s into QF factor. So I want to substitute the values which I got. So I am going to get small d as 23.97. So from the table again 14.6 table, for standard diameter of the shaft will be given as 25 mm. So mean diameter, consider the wear condition. So dm is equals to half d2 plus d1. So d1 again I am going to take d1 is equals to 4d. So I am going to take d1 is equals to 4 into 25, that is 100 mm. And one more equation is given, d2 I can assume as 1.25 to 1.8 of d1, that is 19.90. So I am going to assume d2 as 1.5 d1. So I am going to get as 1.5 into 100 as 150 mm. So dm is equals to half 150 plus 100, so 125 mm. So axial force again, so d2 and d1 is already known, so substitute the values. So I am going to get FA as 8125.73 newtons. So number of disc I have to calculate. So when I go for the number of disc over here, that is I need to calculate I value. So MT is equals to half mu FA dm into I. Previously, since the I is known as directly as 2, I have not taken the d2 formula, but here I have to calculate I directly, so I have to take the d2 as assumed as 1.5 d1. So MT, I am going to substitute the value, and this values I am going to substitute. So I am going to get I as 529. So normally you have to assume there's a even number of plates. So I is equals to 8. So number of disc on a driver shaft, I1 is equals to I by 2, that is 8 by 2 as 4 on the driver shaft. On a driven shaft it will be I by 2 plus 1, so 8 by 2 plus 1 it will be 5. So total number of disc in a given clutch will be 9, and the thickness of the frictional disc I am going to assume as 2 mm. So that finishes the problems on single and multi-plate clutch.